So welcome back. I hope your friends will be able to find us along the way. And I've realized that the network in the afternoon is not usually good. So again, I guess we'll revert back to in the morning, because in the morning it seemed like the network was better. So I'll be able to communicate in the group, so that it's just that on my Tuesdays in the morning, some of my lectures, they started giving us lectures in the morning on Tuesday and on Thursday. So it became challenging. So maybe we can change the meeting days to Wednesdays and Fridays, Sunday, Wednesdays and Fridays, so that because those days I'm free in the morning. So yeah, so we are continuing on with where we ended. Yeah, we are continuing on with where we ended. And one important aspect I was trying to make is that you guys, you have to see what relates to phenomenon, to particular objects, or to, yeah, the phenomenon, the relationship between the two, between the arrow and the wheel. So one thing that for me I saw, which was easy for me to relate between the arrow and the wheel, was time. I thought time can be a good relationship. Since an arrow and the wheel are two different objects, so that the one thing that can relate the two is time. If I can find out the time which the arrow will take to move across its length, to move the whole lot of its length through the spoke, I can use it by calculating, computing the length or the distance of the arrow over its speed, its velocity. I'll be able to find the time, because I know that a distance over speed can give me time. So again, for the what's this? For the wheel, I also know that the distance between the spokes. So I can even write D spokes, distance between the spokes. If I know my distance between the spokes, and I also know my velocity of my wheel, I'll be able to get the time. All right, I'll be able to get the time. Now, this time will be the same, because we are saying the time that the arrow will take to pass through the spoke will be the same time that when this spoke, which is here, would have moved to that position. All right, as the spoke, the wheel will be moving, the spokes also be moving. So awesome. So as the wheel will be moving, we don't want the arrow to make contact with the spokes. So we want, when the arrow would have moved the whole lot of its length, that's when this spoke would have moved to the position of the other spoke. I don't know if you guys are visualizing, are able to follow through my explanation. Are you guys able to follow through what I'm explaining?
Yes, sir.
Yes, sir.
Yes, sir.
Awesome. So let's look at the solutions then. The solution is that, first of all, we need to find out the distance between the two spokes. Between the spokes, we have 8 number of spokes, and so the distance between the 8 spokes is 1/8, and multiply by the 2 pi radius. This is the formula for calculating the circumference. If we can divide it by 8, and then we can know the distance between one spoke and the other. Yeah, so, and this is giving us this as our distance. And so this means that the spoke, one spoke, for it to move to the other position of the other spoke, it will move this particular distance. So this is the distance between the two spokes. So the arrow will need to pass through this distance, but the arrow also has its own distance, which it has its own length of 0.2 meters. So let's find out the time it would take for the arrow to move the length of its distance. All right, the distance of its length. What time would it take for the arrow to move the distance of its length? And here we just, for the time, we get the distance divided by the velocity, the distance being its length and the velocity being 6 meters per second, and then we get the time it will take for the arrow to pass, to move a distance of its length. So the arrow will take this much time to move the distance of its length, and then we use this time to find the speed of the wheel. So like I said, that this time which we find here is the same time that we have here. We know the distance between its spokes, but we don't know the velocity of the wheel. So to get the velocity of the wheel, obviously, we just get the distance between each spoke and divided by the time. So this time that we have gotten from here, from dividing the length of the arrow by the velocity of the arrow, we get a time it will take, because the time is what is relating the two. For the arrow to move through the wheel, the spokes will also be moving. And then if we can get that time when the arrow would have passed through the spokes and then the wheel would have rotated like that, then we would know that the relationship between the two will be the time, because it will happen at the same time. So the time is the same, the time that we have obtained here, we'll use it also in getting the velocity of the wheel. All right, given the distance between each spoke and this time that we have obtained, we can know the velocity of the wheel. Are we together?
Yes.
Yes.
Okay, we have more than 5 people here. I should be hearing a lot of yeses or nos. So which one is which? What do the others say?
Yes.
Okay. 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 Awesome. So I guess we shall move on. So I found the velocity of the wheel. Remember what they were asking us? They were asking us to calculate the maximum speed of, this is the angular velocity. Now, as we have found it in meters per second, we have found the linear velocity. What do we do to change the linear velocity to angular velocity? Someone to help us? Let us have Precious. What are we going to do to change from linear velocity to angular velocity?
We're supposed to multiply.
We multiply what?
Divide by radius.
Okay, Simbarashi has told us. So we actually divide by the radius. We multiply by the radius if we want our linear velocity, and then we give
by 2 pi.
Okay. I don't know if it's your network. I'm not getting you clearly, Precious. But just a quick one. We are saying that if we are given the, if we have found the, if we wanted to find the linear velocity given the angular velocity, we multiply it by r. But if we want our angular velocity given our linear velocity, we divide by r. So here we have found the linear velocity. This is linear velocity, v, wheel, the linear velocity. Now, for us to find the angular velocity, here is where we get our velocity of the wheel divided by the radius, and this gives us this this angular velocity. All right. So that is how we can find the angular velocity of the wheel given a question like that one. So it's all about just finding what relates the two. Is it usually time is what relates the two? In most instances, you'll find that when you're finding motions of two objects or two instances or two scenarios, time is a good relationship. Even in projectile motion, you discover that if you are relating the motion in the x-axis and the motion in the y-axis, you find that time is a good key player, and it helps us determine these things. So, like I always say, physics will require you to think a bit, especially physics at the university. Given a question, don't just look for where is my equation, let me plug in. It's about thinking. Okay, I've been given this information, then you process it, because you should have been bathed in the knowledge of what the question is talking about, and given the tools to analyze such a problem, you should be able to come to a solution. So I guess this is all for today.
Sir.
Okay.
Hello?
We have a question from Simbarasha, then also
Yes.
from Wisdom. Okay, we can start with Wisdom. What's your question?
Yes, my question, sir, is now finding the distance, sir, we use the 8 spokes. Now, what if you use 2 spokes because the arrow passed through between 2 spokes? What if you use those 2 spokes?
Yes, Mr. Gilbert. If you saw it properly, we didn't use 8 spokes. We said we have 8 spokes. But to know the distance between one spoke and another, we divide have you seen this one? 1/8 spokes. So because we were trying to find the distance, this is the distance of the circumference. If it has been split into 8, okay, let me draw it properly here. We have our spokes cutting across like that. So if I know my distance across the whole wheel, for me to know the distance between this spoke and the other spoke, I will divide my distance of the whole wheel by 8. So if I divide my distance of the whole wheel, my circumference of the whole wheel by 8, I will know the distance between 2 successive spokes. And this is what we did here. We divided by 8. We didn't use to say we are getting the whole number of 8 spokes. No. The dividing by 8 was so that we get just the distance between 2 spokes.
All right, thank you, sir.
Yeah. Simbarasha, you had a question?
Yes, sir. Concerning if the question was telling us to say whether the arrow passed through the rim. So we say we're supposed to compare the times, like the time at which the wheel will move through that distance, the 1/8, and what was the other one for the arrow?
Yes. What's the
I
question?
didn't get how you find the time for the arrow, how when it passes through this thing.
This other part, you mean this other portion which is talking about to say, does it matter where between the axle and the rim where it passes through? Is that what you're talking about? Because your network is not sounding very clearly. I'm not able to get you clearly. What are you talking about?
About how do you find the time when the arrow passes through the rim, like the time when it finishes through?
Yes, this is what we're talking about. How you find the time the arrow passes through the rim is, for you to get a time, you know the length of the arrow. If you divide it, because one thing that you need to know is that the arrow will have to move, the whole lot of its length will have to move across those two spokes. So if the whole lot of its length will have to move across those two spokes, then what you have is the length, the time will be the time it will take for the whole length to pass through, given the velocity. So this is the velocity that we have. The length over the velocity will give us the time it will take for the arrow to move the whole lot of its length. Now, this, if we know the time it will take for the arrow to move the whole lot of its length, we can use that same time to know the relationship of saying, okay, the distance between two spokes, over the velocity of the wheel. All right. It should be the same time. This time should be the same time. So that same time it will take for the arrow to move across the whole lot of its length will be the same time it would take for the two spokes to move, one spoke to move to the other, given the velocity of the velocity of the wheel. Now, since we were able to find the time using this equation here, meaning even here we have already found this time, but as we are looking for this now, on this other part, we are looking for the speed of the wheel. So to find the speed of the wheel, velocity of the wheel, now here we are talking about, this is the linear velocity. This is linear velocity. The linear velocity of the wheel, what we did is we just got a distance of the two spokes over this time that we have calculated. We were able to find the velocity of the wheel. Is that clear?
Yes, sir.
Awesome. And mind you, I've only calculated the answer in radians per second. I would like you guys to also calculate in revolutions per second. All right, that will also be part of the homework. You also calculate in revolutions per second. And again, there is this other part which is saying, does it matter where the axle and the rim of the wheel you aim? So you have your spokes like that. So does it matter? Yes, it matters. You have to aim. If the arrow is moving that direction, you have to aim at the edge of one spoke. So in fact, not at this edge. You have to aim at that edge, at the edge of one spoke just below the rim, so that when you aim, this spoke will be moving outward like that. And then this other spoke will be coming as the arrow will be passing. So just below the rim at the edge of one spoke, that is where you have to aim, so that as the other spoke will be coming to cover that distance, your your arrow should have now already come out from there. Is that clear on where you are supposed to aim? Have you gotten it?
Yes, sir.
Yes, sir.
Awesome, awesome. So, yeah, that is what we have. But again, we have a homework here, my friends, and I would need you to solve it. This homework, I'm going to send this document, and then you can get working on the homework so that when you finish, you send. And some of you guys have now about, I don't know, 20 homeworks that you have not sent yet. Okay, Simbarashi, since your network is not okay, can we continue the discussion on WhatsApp so that I can be able to hear you clearly, so that we can end this meeting?
Yes, sir.
Yeah. But anyway, even before we end it, is there anyone also with a concern? Anyone who would wish to ask a question? Are we all okay on the solutions and some of the explanations? Are we okay?
Yes.
I'm fine.
Awesome. Awesome. So I hope you guys have a wonderful afternoon, and study well, pray hard, work hard, and play a little. But yeah, you have to maintain the focus, and yeah, so I guess hopefully we'll meet again next time we're having a class. So I'll be able to discuss with you guys whether we should have a class on Wednesday. We'll be having classes on Wednesdays and Fridays at 10 hours, or we should maintain the 14 hours, because usually on Tuesdays and Thursdays, I'll be busy with other classes. So I'll be able to discuss in the group. But yeah, I guess have a wonderful afternoon.
Thank you, sir.
Awesome. Awesome.